All right, so we're looking at conic sections and parabolas. You've already seen, like I said, you've already seen all of the conic sections that we're going to go through in the next few days here. Today we're looking at specifically parabolas, and then the next 2 days we'll look at ellipses and hyperbolas. So let's first talk about what a conic section is. Please don't copy this all down, just look at it, okay? I don't want you to write this down. A conic section basically is formed if you take a right circular cone with two sections and you think about, if I were to find a cross section on this thing, what are the different types of shapes I could get? So what we do is we start with the horizontal cross section, which should give you a perfect circle, right? Notice that they're starting to tilt this thing so that it's tilting this way, right? So they're kind of lowering this end of the board and seeing what happens. Yeah? So as they start to lower this end of the board, your circle goes from being a perfect circle to being kind of an ovular shape, which we call an ellipse. As I continue tilting this, I am eventually going to hit a point where I tilt this far enough that that plane becomes parallel to the slope of my cone. When that happens, this blue plane is going to never cross through this side of the cone. Do you guys see that? So like no matter what happens, it's not going to be like an ellipse where it crosses through this side of the cone. If it's parallel, it can't do that. So that's what forms the parabola, is that it will just be this U that keeps on going up and up and up, and it will never, ever, ever close off to form the ellipse. Keep on tilting it, and eventually you'll hit a vertical line, which will give you a hyperbola. So the hyperbola is where you get the U shape up here. Again, that will go on forever. And then the U shape down here. So you get that double parabola shape. That's where conic sections come from. Notice the word conic comes from, what do you think? Cones. That's why we call them conic sections. It's because they're formed from the conics. The equation form. This just shows you what components in your equation you might have, but you might not have all of these components. Okay, so for an example, when we look at a parabola will not have an xy term, right? And it will only have one of these two. It will have either a y squared term or an x squared term, but not both. So these are the different options you have for your terms, but you might not have them all. Questions on that? Okay. So the parabola, you guys already know a lot about parabolas. This is kind of a new definition for it because I'm going to introduce a focus and a directrix. And I'm not sure, but do those two words sound familiar? Those might be new, or did you guys learn focus and directrix last year? Focus at least. Okay, so directrix might be new. So basically, you guys, in the cup part of a parabola, you get a focus, and the focus is a distance of p away from your vertex into the cup. Right? So one of my students in my last class kind of said it in a way and said, you pee in a cup. Okay. So p, distance of p, in the cup. Okay? The directrix is that same distance, but it's like the table that the cup is hovering above because let's say that you have magical p and it makes a cup float. Okay? But again, a distance of p away, and it's like the table. So the cup is going to sit perfectly on that table but hover above it, right? So a parabola has a definition that's a little bit more precise about where it comes from. A parabola is essentially the set of any point such that that point, the distance from the focus to that point is the same distance as if I take that point and drop a perpendicular line down to the directrix. So that distance right there is the same as that distance. And that will be true for any point on the parabola. So like if I came down here, the distance to my focus is the same as the distance of dropping a perpendicular down to the line, to the directrix. Any questions on where the focus goes, where the directrix goes, and what the relationship is between the two? No? All right. Yep. Hold on. Some relationships, you guys, just to kind of talk about as you guys are copying. Notice that from the vertex to the focus, one of your variables will stay the same, right? So in this case, which variable did not change? X or Y? To go from here to here, what do they share in common? X. So your focus should always share either the X or the Y, depending on whether your graph is opening up, down, or left or right. Okay? But you can steal one of the vertex's coordinates, and then you just add or subtract that distance of P from the other coordinate, depending on which way your graph is opening, right? Does that make sense? So that's going to be definitely a relationship that we're looking at here. Did anyone need any more time with this up? Okay, so like I was just talking about, you might have horizontal parabolas, right? When you're looking at these, a vertical parabola can open up or it can open down, right? Here's your focus that's in the cup. Here's your directrix that's like the table it's hovering above. And also notice what else did I put in? Axis of symmetry, which is something you guys already know, right? Axis of symmetry. So I'm not really going to talk too much about that. That's something that should be for sure a review. Notice that for the horizontal, it can open left or right. Focus is still in the cup. It's just that your cup has now turned, right? Notice that this is still a table that the cup would be hovering on with its bottom side facing towards it, right? So now my directrix is a vertical line and my axis of symmetry is a horizontal. Notice that the axis of symmetry and the directrix should always be perpendicular. What's the other thing to take note of? So if I give you an equation, how are you going to know whether you have a vertical or a horizontal? What tells you that?
Which variable has the square?
Right, which variable has the square? Notice this is a little bit confusing, just a tiny bit. I mean, once you know it, you know it. But a vertical has the x is squared. And a lot of people will kind of want to get that mixed up because usually x means horizontal, right? But if you have an x squared term, that means you have a vertical parabola. If you have a y squared term, that means that you have a horizontal parabola. And that's how you're going to figure that out. So this first example that we're going to look at is just kind of looking at the very basics of what we just talked about. Notice that there's 4 graphs, 5 equations, so one of these won't match to anything, right? How can you be efficient about this? Like, when you're looking for this graph, what are the key characteristics of this graph that you are looking for in your equation? Vertex you might look at, right? What else might you look at? Which direction it opens. So based on the direction of opening, what variable do you expect to be squared? X, because it's a vertical graph means x squared, right? If your vertex is at 1, 2, what do you expect that squared factor to look like? X plus 1? Minus 1. Good. Yep, so you're expecting part of your equation to look like x minus 1 squared, and then the other part to look like y minus 2 without the square, right? And then there might be a coefficient on that. Now, what are you expecting about the coefficient in front since this opens down? Negative. Do you guys see that anywhere here? C. So you've got y minus 2 like we talked about, x minus 1 squared, and you've got a negative coefficient so it opens down. Very good. So let's go ahead and mark this as graph C. Cross it off our list. This one. Tell me about the characteristics you're looking for. Don't tell me which graph yet, just tell me about what characteristics you're looking at. Y is squared because it opens horizontally. Good. So we're looking for a y squared. What else are you looking at? Positive or negative coefficient? What? Positive because it opens in the positive direction. Yep. What else? Vertex is at 2, 1, so you expect to see a term that says x minus 2 and y minus 1. Do you guys see that? Which graph? B, right? We've got our y minus 1 squared that we talked about. You've got your x minus 2 and a positive coefficient. So this is graph B. Very good. All right, look down here. Let's do it this way. What changes between this graph and this graph? Because they're both horizontal, right? So my graph is going to look similar to this. What about this equation should change for this graph? Should the vertex be at the same spot? What point changes on the vertex? The x, right? And it's just the sign on the x that should change. So this should be changing to an x plus 2. How about, what else? The fact that it opens in the opposite direction, what else does that tell us? Negative coefficient, right? So that would be this equation right here. Change to a plus 2, and we tacked on a negative coefficient. So that is graph E. How about this last one? Opens which way? So if it opens up, which variable should be squared? X. We really only have one of those left, but let's check it to make sure that all is well, right? So this vertex is at positive 1, negative 2, which means I want x minus 1, y plus 2, which I've got, right? And a positive coefficient since it's opening up, which I also have. So that is graph A, and we've matched them all. D was the equation that did not fit anything else. Any questions on that? Okay. So the next few examples are getting more and more difficult, but basically you're looking for the same thing out of each. You're looking for the vertex, the focus, the axis of symmetry, the directrix, and the direction of opening. And then we need to draw the graph with the 5 main points that we've always plotted. All right? So let's take a look at this equation. When we're looking at, oh, and you guys, I think I forgot to point out something. Let me go back up a couple of slides. You already have it written down, but I just wanted to point out. Notice that the coefficient in this form, the way that we find p depends on the coefficient being attached to the non-squared variable, right? So if your coefficient is on the squared variable, you're going to have to move it over to the non-squared. Okay? The other thing is that this coefficient is the distance for p. So p is going to be whatever your coefficient is divided by 4, right? That's going to tell us how far to go for the focus and the directrix. So I meant to mention that before, but now we're going to make use of it in this example. So the first thing I'm going to do is get it formatted like that last slide I just looked at. So basically I want my x squared to stay on one side, but I'm going to put everything else on the other. Based on this, can you guys tell me, and I usually like to start with the direction of opening. So can you guys tell me which way this opens? So the fact that you have x squared means, is it vertical or horizontal? Vertical with a positive coefficient means it opens up, right? Can you tell me what your p-value is? Huh? Why is it 1? Mimi, why is this coefficient 1? Nope. Make sure you're paying attention, please. Shane?
Because in the equation it's 4p, so you put
Right. Remember, I just talked through on the last slide that you take your coefficient should be 4 times p. So if your coefficient is 4, we want to take 4 divided by 4, p is 1. It's always that coefficient divided by 4, assuming that the coefficient is attached to the non-squared term. So now I can start going through and doing my vertex and everything else. I've got my vertex, which is at what? 0, 0. And from my vertex, remember I said I can find the focus pretty easily. Either my x value will stay the same or my y value will stay the same. Can you guys tell me for this particular graph, when I put my focus where it belongs, remember your focus goes into the cup. So does my x value on a vertical graph going up, does my x value change horizontally or vertically? Vertically, which means my x value does not change, right? So that means that my focus is still at 0. And how much am I going up to get to the focus? Distance of p, right? So I'm going to go up to 1. Your directrix is what kind of a line, horizontal or vertical, for this direction of opening? It's going to be horizontal so that it looks like a table, right? How do you write a horizontal line? Y equals, and then I'm going to be going down from my vertex. So if my y value on my vertex was at 0 and I go down, it's going to go to -1. And then my axis of symmetry is always perpendicular to the directrix. So if this is my directrix, then I know that my axis of symmetry has to be an x equals equation. And it's going to be an x equals whatever goes through the vertex. What's your x point on the vertex? So it has to go through x equals 0. So you can see, you can do all of that stuff without having to draw the graph, right? Just kind of thinking through. The biggest key factor is the direction of opening. That will tell you where to go for everything else. So now I have to plot it, and the trick is going to be getting the 5 points. We're going to have to kind of think about that for a second. So first, let's plot our vertex. So that's going to be at the point 0, 0. My focus is at 0, 1. My directrix is at y equals -1. And you guys, you don't have to label things on your graph as long as you've written them off to the side and labeled them for me over here. So as long as you've said V is 0, 0, F is 0, 1, blah, 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 then I'll just check to make sure your graph has the same points, right? But you don't have to label anything on the graph as long as you've written it off to the side. Okay? And then I also have my axis of symmetry, which is my vertical line. And now what I need to do is figure out how wide this graph opens by finding those 5 key points. Okay, so the way that we do that is just how we used to do with the vertical stretch or the horizontal stretch. Okay, basically what you're going to do is make a T-chart whichever is your squared variable is going to go first and your non-squared goes second. So if this was a y-squared situation, I would set up my T-chart so that I had y over here and x over here, right? What distances do we usually move out from a vertex when we're counting our points? We usually go out 1 in both directions and out 2 in both directions. And usually that would result in vertical movement of 1 to 4, right? But what you have to keep in mind is, remember your vertical stretch or shrink. In the past, we've always done the vertical stretch or shrink is the coefficient on what? On the squared term, right? I'm not sure what just happened up there, sorry. It's whatever is the coefficient on the squared term. So I'm just going to kind of write something up here really quickly. You're used to looking at these as y equals ax squared plus bx plus c, right? Or if this was a horizontal asymptote, you might look at it as x equals ay squared plus by plus c. So maybe just switching the x and the y. But notice that a is your vertical stretch, right? And so a is the coefficient on the x squared term, assuming that you have completely solved for the other variable, right? We are always looking at this where I have put the coefficient on the variable that in the past we've always put alone. Does that make sense? So basically, what's going to end up happening is if I wanted to know what the coefficient on my x squared term was here, I would divide the 4 over, right? So when I'm in this form, and that will always be the case. So when I am in this form, my vertical stretch or shrink is always going to be the reciprocal of this coefficient. Does everyone understand why that is? Or does anyone need me to explain that one more time? Okay. So this means that I have a vertical shrink of 1/4 because, like I said, I'm taking the reciprocal of this thing, right? So that means that I need to shrink these vertical movements by 1/4. So what this says is when I go out in the x direction of 1 in either side from the vertex, I'm going to go up 1/4. And when I go out 2 in either direction from the vertex, I'm going to go up 1. So that looks like this. Out 1, up about 1/4. Out 2, up 1. And now that gives me my 5 main points, and I can just sketch in my parabola. And I should be going through that bottom point a little bit better. I just got a little off on here. All right, are there any questions on how we're graphing these? Yes?
If we have the t-chart, do we have to label the points?
No, if you have the t-chart right here, that's enough. You don't have to label these points. Okay, but I do want to see something, either the points written out or something to show me how you knew where you're moving and that I know that you're actually on 1/4. Like if this wasn't here and you just had these 2 points here, I would have no idea what values you were thinking these were, right? So you've got to indicate somehow to me that you knew how you were moving. All right, the next one gets just a hair trickier. Not much though. What do I have to do first of all? Remember, in this form, the squared term, should it ever have a coefficient in this form? Huh? Yes or no? No. In this form, your squared term should never ever have a coefficient. That coefficient always needs to go on the other side. And the squared term always needs to be by itself, right? So what I am going to do is add my 4 over. So I'm going to say that this is x plus 4. Oops, just kidding, hold on. I forgot to put on my righty thing. All right, so I'm going to write this is x plus 4 by adding the 4 over equals 2y squared. And then I'm going to take half of both sides so that I get y squared by itself. So I'm going to say y squared equals 1/2. Leave it out as a coefficient, right? I need it in that form anyway. So 1/2 x plus 4. This now is in that form that I wanted, where I've got my squared term by itself, I've got the other variable on the other side with its shift, and then the coefficient in front. Okay, first step. Remember I said will make your life easier, no matter how they list it in the direction. So you'll notice that out here they said find the direction of opening last. I always want to find that first because it tells me how I'm going to move for my focus and my directrix and everything else, right? So which direction does this thing open? To the right. Yep, you've got a y squared, which means horizontal. Positive coefficient means opening to the right. What's your p-value? How do you find it? Huh? Divide the coefficient by 4. Yeah, and so that looks a little weird at first because I'm asking you to take 1/2 and divide it by 4, right? And I don't really like to write 1/2 over 4, right? So instead of dividing by 4, I can multiply by 1/4, and that's just an easier calculation. But either way, you should get to p is 1/8. All right, so now I'm ready to start listing out what I know. I know my vertex is at what? X value for my vertex? -4. Good. Y value? Which one of these values is going to stay the same for my focus when I'm opening to the right. The y value now stays the same. Yep, because if I'm going to go into the cup, I'm moving horizontally. So my horizontal component is the only one that should change. So for my focus, I get to steal the 0 for my y value. For the x value, am I moving to the left or to the right of my vertex? Which way? To the right. So I am taking negative 1/4 and I am adding 1/8 to go in, right? So I'm just going to write that as a mixed number. What is negative 4 plus 1/8? Negative 3 and 7/8. Very good. All right. There's my focus. How about my directrix? Where is that going to go? What kind of a line is it and what equation does it get then? So you can see this would have to, in order to have the cup hovering above the table, right, it would have to be a vertical line, which means it's an x equals equation. And what does x equal for that directrix? What? Negative 4 and 1/8. So remember that to find the directrix, you go back a distance of p. So if my vertex's x value was at negative 4, and I go back 1/8, that's going to take me to negative 4 and 1/8. Any questions on that? Axis of symmetry? It's y equals, and then you can just steal it from the vertex. So which value do I steal from the vertex? Y equals 0, and you're done. So let's plot that stuff, and then I'll get ready to look at my vertical stretch or shrink. Vertical or horizontal, I guess, since I'm opening the other way. All right, so I've got my opening is at negative 4, 0. Everything's going to be pretty squished in tight here, yeah? Because I'm only able to go back 1/8, and mine's going to be pretty tight, but to the directrix. Mm-hmm.
So that directrix is just dashed, just to differentiate it from being a normal line, right? It's not.
Yeah. Right. It's not an asymptote. No. Okay. And I guess you don't have to dash it. I just do. And then 1/8 in the other direction, so it's really close to my vertex. That little point is the focus. And now I have to figure out how wide to open. Notice that this time, instead of going out 1 in a horizontal direction and then out 2 in a horizontal, I'm going to be moving from the vertex out 1, out 2 in the vertical direction, right? So that's why I told you guys when you're making your little T-chart table, sometimes the y is going to go on this side. This is that case. When you have a y squared equation, then the y value is the one that moves by 1 and 2. It's now the x value that is going to be possibly shrinking or stretching, right? Still has that same pattern where it's 1, 4, and you're still going to multiply by the reciprocal of your coefficient. So what is the reciprocal of this coefficient? 2. So I will be multiplying each of these guys by 2. So this means that when I go vertically 1 in either direction from my vertex, I'm going to go horizontally out 2. When I go vertically 2 in either direction from the vertex, I'm going to go horizontally out 8. So what does that look like? 1 vertically, 2 out horizontally, out 2 vertically, and I'm going to go out 8 horizontally. And then that's a really narrow parabola, right? Any questions on that? I think, honestly, the trickiest part to me, I think, is right here, is getting that stretch and shrink correct, right? And still, that's a review. But all of this should be pretty straightforward. Yeah? I'm not sure what you're saying. Oh, like you say list the coordinates?
Yeah.
I already said this. Yes, you can either put the coordinates on the 5 points, or you can indicate to me how far you moved so that I know that you're at the right spot. As long as there is some sort of indication of how you got to those points or what they are exactly is fine. All right. For this one, determine the vertex, the focus, the axis of symmetry, same old stuff that we've been doing. What's the only thing? So this one's actually easier than the last one in the sense that is it already in the correct form? Yeah, no coefficient on the squared term, right? Everything else on the other side. So this is already in a good form. What's the one thing that makes it maybe a step more difficult than the last one? Just that the vertex is shifted in both directions, right? That's it, really. So for this one, I don't have to do any rearranging. I can just start. Which way does it open? Horizontal or vertical? Horizontal, because we have y squared. Negative meaning to the left, right? Okay? Which value do I need to find before I start doing anything? How do I find p? How do I find p? Divide what by 4? What is the coefficient? Okay. Divide negative 20 by 4 gives you negative 5. The negative on this basically just tells you you're opening in the negative direction. That's it. It means the same thing as opening left. Okay, what is your vertex? Negative 2, 3. Good. Make sure you're looking at the x pairing when you're looking for that coordinate. For this, which coordinate out of the vertex is going to stay the same for the focus? The negative 2 or the 3? Good. The y value stays constant when you're opening horizontally. Only the x value will change for the horizontal opening, right? And I know that I'm starting at negative 2, and I'm going left by a distance of negative 5. So where does that take me? Negative 7. Directrix goes in the opposite direction by the same distance. So if I started at negative 2 and went left last time, I'm going to start at negative 2 and go right. What's negative 2 plus 5? And what kind of an equation is it? X equals to open vertically. Very good. And vertically again because you need that kind of hovering table. So if that's x equals, what do you know about your axis of symmetry? It's a y equals equation, and you just steal what y? The vertex, which is 3 as well, right? Okay, let's do our vertical stretch and shrink right now, just so I'm all ready to go. Which variable do I put in the first column? Y, since it's a y squared, and then x will go in the second. Moving by 1 and 2, 1 and 4. What do I need to multiply these guys by? 1/20th, right? The reciprocal of the coefficient when it's in this form. So that will be 1/20th over 1/5. So definitely some kind of annoying movements, right? The other thing that I have to watch is that I'm going to have to scale my axes because I have to get to negative 7 and this graph doesn't. So I'm going to go by 2's on both axes. Okay, so I'm going by negative 2 here, 2 here. So when I'm plotting this vertex, my vertex is at negative 2, 3, which will be about right here. My focus is at negative 7, 3, which will be out negative 2, negative 4, negative 6, and then one more, so right here. My directrix is at y equals 3. which will be right here. Oh, I think I've been forgetting to put in my axis of symmetry, but you guys can go back and do that. Just goes through the focus and the vertex, right? So there's my axis of symmetry. And now all I have to do is my direction of open, or not my direction of opening, but my points that give me my width. So notice that this is going to be a really wide graph, because when I go out 1 in this direction, and remember I've gone by 2, so I'm only going to go up half a unit, because that will be 1, right? So when I go out 1, I'm only supposed to be moving in the left direction by like 1/20th. So I'm like essentially still right on that, just a hair over from that -2 line, right? And then I'm going out 2 and then over 1/5. So I get to go a little bit more over, but still not a whole ton. And again, keep in mind we're moving by 2, so I'm not jumping up to the next line. I'm going to be halfway in between. So I'm going to be kind of like right here and right here. So you can see that this is a super duper wide graph, right? Should look something like this. Any questions on that? Okay. Oh, yeah.
On our y and x grid,
Uh-huh.
we multiplied it by a positive reciprocal, not negative.
Yeah, that just told me you could multiply it by a negative. I just knew I'm heading left, so I'm going to go that distance to the left. So you don't have to put the negative on because you've already told me which way you're going to go for them. You're just trying to figure out how far in that direction. If you put the negative on, that's fine.
Right.
Yep. All right, last one of the graphing. What do you notice? Huh? Yay, yeah, that was quick. So you have to complete the square. How do you know you have to complete the square? What term in there indicates that you have to complete the square? The what? Which term? X squared, 2x, 2y, or 5? 2x. Right? That's what is stopping you from just having an x squared term, right? Is like if I didn't have this term right here, all I would have to do is subtract the 2i over, add the 5 over, and I'd have x squared by itself, right? The problem is I have this term, and I really need this side of the equation with the x's to just be x plus or minus a number squared. So that's when you complete the square to get that. All right, so let's start doing that. If I'm going to complete the square in this guy, hold on. If I'm going to complete the square in this guy, I'm looking at just these terms for the completing of the square, right? What do I have to add in after that in order to make that be completed? What? What am I adding? 1, right. Divide that middle term by 2, square it. So 1. I'm also going to take this step to move everything else over to the other side. So that's going to look like negative 2y plus 5. But if I added 1 onto one side, I can't just do that. I can't just add in a 1. What do I have to do? Add it to the other side to keep it balanced. Very good. So now when I'm looking at this, what does the left-hand side here turn into? Good. X minus 1 squared equals this 5 plus 1 is going to end up being 6. So what, though, do I have to do to this side? Can I just leave that as negative 2y plus 6? No, what do you have to take out? You have to take the negative 2 out, so that will be y minus 3. What that affects, you guys, it doesn't affect what your coefficient is going to be, but what does it affect? It affects your y-coordinate for the vertex. If you left that as a 6, you're going to be pretty far off from where you need to be, right? Okay. So now I'm in the correct form, and I'm ready to start. Which way does this open? Down. Very good. What's my p-value? 1/2 or negative 1/2. And again, it really doesn't matter to me if you attach that plus or minus. This right here is telling me that you interpreted the negative correctly, right? When you tell me what direction it opens. So you can say p is negative 1/2 or positive 1/2. It doesn't matter. But how did we find that? Divided it by 4. Very good. Okay, what is my vertex? Good, 1, 3. Whoever's making that noise needs to please stop. Thank you. Focus. Which variable stays the same? The x, right, because it's a vertical movement now, right? So I'm going to steal that 1. Am I adding or subtracting p from 3? Well, I guess it's kind of confusing because I made it a negative, but 1/2. Am I adding or subtracting 1/2 from p? Subtracting, right? Because I want my focus to go down. So that will be 2.5. Where does my directrix go? Up from the 3 by 1/2, so it will go up to 3.5. And what kind of an equation is it? Y equals, because for a vertical parabola, we want a horizontal line, right? Knowing that, what's my axis of symmetry? X equals, and I steal the 1. T-chart. Which order do I put my variables here? X, Y, 1, 2, 1, 4, and then what am I multiplying them each by? Huh? 1/2, right? You're multiplying by the reciprocal of this coefficient, right? So you're multiplying by 1/2. So I'm going to move by 1/2 and by 2. All right. So I'm going to start plotting all this. My vertex, I said, was at 1, 3. My focus was at 1, 2.5. My directrix was at 3.5. Axis of symmetry is down on 1. When I go out 1, I'm going down 1/2 based on my table. And when I go out 2, I'm going down 2. So this is a pretty standard looking, it's not exact, but it is, you know, a pretty normal opening. Not super wide, not super narrow. Any questions on how to graph? This one, the setup is the most difficult because you have to complete the square. But once you've got the square completed and you've got it in the right form, all of this stuff should be, you know, all the same as far as difficulty goes. So it's just whether or not I give you an equation in the proper form and how to get it into that form if it's not, is kind of the tricky part to the problem. All right. So now we're going to kind of go backwards. This time I'm going to give you information about the graph, and I want you to write an equation of the parabola that satisfies the conditions. The easiest thing to do is just kind of to plot this stuff and figure out. The biggest thing that's going to help you is what? What do you think you first must figure out? What was the biggest thing that helped us on the last thing? What was the very first step? The direction of opening, right? Because that's going to tell you whether you have an x squared or a y squared equation. It's going to tell you whether you have a positive or a negative coefficient, right? Things like that. That's going to be really important. So let's go ahead and kind of see where this stuff is. I'm telling you, if I give you this little grid, I'm just going to draw a little mini picture of this. I've got a directrix at x equals -4. What kind of a line is that? It's a vertical line, right? So that's going to look like this. Then I have the vertex at 3, 2, which is going to be right there. That's the focus, right? So can you guys tell me, based on that information, which way is this opening? It's opening to the right. That's the only way that you can have this directrix and then have the vertex, or have the focus be in that cup, right? Can you tell me what your distance P is? No? Remember, your vertex is somewhere in between that focus and the directrix, right? Specifically, it should be exactly halfway in between. And if that's the case, how big is your P? 3.5, 7 halves, however you want to write it, right? I'll keep it as an improper fraction. All right. Can you tell me where the vertex is? Yep. So remember, that vertex is going to have to be exactly in between, which is going to be going back 3.5, such that when I open this, so the vertex has the same y value basically, right? But it's going to kind of look like this. So my vertex is at -1/2, and then still up on, is that 2 or 3? Carry 2. So this is all the information I need to write my equation. First of all, is it an x squared or a y squared equation? Okay, so when I set this up, I'm doing y minus 2 for the vertex. I know that this is my squared part. What's the coefficient going to be in y? 14, because the coefficient should be 4 times p, right? So if I do 7 halves times 4, I get 14. I'm keeping it positive because it's opening in the positive direction. So that's going to be 14, and then x plus 1/2. And you're done. Questions on that?
Do you always put x coordinate to the vertex to be x, like for the, is y minus 2, and then 2 is the y coordinate of the vertex?
Vertex, yep.
Is it always y is the y coordinate minus paired x coordinate, or does it depend on?
Wait, what?
Is it always like
The-
y is paired with the y coordinate of the vertex? And x
Yes,
is
yes,
the
yes.
X coordinate no matter.
No matter what. Yep.
Alright.
Can you explain how you get 14 one more time?
Yep. So this coefficient here in our equation from like one of our first few slides is supposed to be 4p, right? And p is 7 halves. So if you multiply 7 halves by 4, you get 14.
Okay.
All right, one more. So this one I give you slightly different information. This time I'm giving you the vertex and the focus. So again, kind of plot it so you can see what's happening. I've got my vertex is out at 5. Seven, and my focus is in at 2, 7. If this is my focus and this is my vertex, which way does the graph have to open? Yep, it has to open this way so that that focus is in the cup, right? What is your p-value? 3. And that's all we need to know for the equation, right? We know the vertex already. All I needed to figure out was p. That's all I need for any of these equations is direction of opening, p-value, and vertex. So first of all, is this an x or a y squared? Y squared. It still is opening horizontally, right? So this is still a y. My vertex has a y value of 7, so y minus 7 squared equals, what's my coefficient? No. No. Think about your direction of opening, guys. Negative 12. Yep. You had the number right, but you do have to put the negative on so that it opens to the left, right? All right, and then I just do x minus 5 for my x values vertex point. And I'm done. Any questions on that? No? All right, last example. A spotlight has a parabolic cross-section that is 4 feet wide at the opening and 1.5 feet deep at the vertex. How far is the vertex from the focus? So, let's draw a little sketch of this. They're telling us that we've got this parabolic opening, so it kind of looks like a dish, right? Whoa, hold on. I can't seem to get the end of that to look nice. Parabolic opening where the width at the opening they're saying is 4 and the height at the opening is 1.5. What is the distance from the vertex to the focus? No, but I'm glad you said that because that is the biggest mistake. By biggest, I mean most common mistake. Did I guarantee you guys, so think about any parabola, right? Let's say that here's the focus. Did I guarantee you that I cut right through the focus? Did I say that? No, so couldn't I have cut here? Could I have cut here? Yeah? I did not guarantee that the height I gave you was through the focus. So your 1.5 might be below or it might be above, right? So now what? So what value is it that we're looking for in terms of everything we've been doing? What is that called? P, right? Yeah, and in order to put that in an equation, don't I need to put this in a graph? So what would be the easiest point to make the vertex? Yep, the origin. So what I am going to do is superimpose a graph on this thing so that my vertex of it is, hold on, let me redo that one. So that my vertex is on the origin. Like I said, you don't know if your p-value might be up here. You don't know if it's down here, right? You're not sure. That's not guaranteed to be the 1.5. But can you guys start to write an equation that represents this situation right now? What are you going to have, a y squared or an x squared equation for this? Huh? Yeah, you are going to have an x squared because it opens vertically. So you know it's x squared. Do you have an x value to subtract? Do you know what I mean? So am I doing x minus or plus a certain value? No, because I'm centered at the origin. I made that nice for myself. This is just x squared because the vertex at the origin is 0, right? Equals, I don't know what p is yet, so the best I can do is write, well, my coefficient is going to be 4p, and then I would do y plus or minus the y-coordinate, right? But that's also a 0 since it's on the axis, so this is just 4p times y. So if I wanted to find p, what would I have to plug in? You'd have to plug in a xy pair. That's not 0, 0, because if you do 0, 0, then you lose your p, right? What is a point that you know that is on your graph? Huh? Yeah, you know this point has to be at 2 since it's half of the horizontal cross-section, right? And it's up a y value of 1.5. So I'm going to plug that in. I'm actually going to use 3/2 for the 1.5 so that it's easy to deal with. So I'm going to do 3/2 squared equals 4p times my y value. Oops, I did that backwards. I'm sorry. Let me go back. So my x value is just 2. My y value I'm going to write as 3/2 because I like it better. It's easier. Homework will be on Schoology. So this gives me 4 equals 4p times 3 halves. And actually, I can kind of make that a little bit better. What is 4 times 3 halves? So 6p. So p is equal to 2/3, right? So p for us is actually halfway down this thing. Or not halfway, I'm sorry. More than halfway, right? If it's a distance of 2/3. Some of you guys might be looking at that and saying, oh, well, it was the reciprocal of what you gave me. That was just coincidence. That will not always happen. Don't try and use that pattern, all right? This is going to be your strategy, is to superimpose your parabola on a graph at the origin, write the equation. It will always be a simple equation if you put it on the origin, right? You have an xy coordinate, plug it in, solve for p. Any questions? Yes?
So if it was open horizontal, would you switch things in the line?
Yeah, it would still work. I mean, I just happen to draw mine vertically, right? You could draw yours horizontally if you wanted to, but I just liked it opening vertically. You would still get the same answer. Yep. All right. So that is that. Here is your homework. You guys, for the first few, listen up. For the first couple of problems, they're going to ask you to find the focal width, which I did not teach you. Just skip over the focal width. We all hear that? So again, when they ask for the focal width, you're just skipping over that part. But you will find the focus, the directrix, and whatever else they ask for. So this will be due on Monday. I'll only probably give you about 10 minutes of homework review on Monday. So basically just enough time to check your answers. And if you need to clarify anything with me, please do it after class on Monday. Tuesday, and then Monday we'll be moving on to ellipses as well. Remember, test next week.